This time I got an old Sparton radio. This was made in Canada in about 1934, 1935. It's an AM shortwave radio that was brought in for me to check out. We're going to be servicing this one. This video right now is going to be an evaluation video just to make sure there's nothing seriously wrong with it. Make sure the tubes and stuff work. We're going to get the unit working. I'm not going to finish it in this one, but at least we're going to get the unit producing sound, and then we'll go with it from there, is what we need to do to finish it up. Today I have an old Sparton tube radio. Got a few marks on it, but this would go back to the, I think, probably the mid-1930s. It's got your standard broadcast band as well as a couple shortwave bands. Cover, looks like it covers, this is the top end of the AM band. So you got your standard 540 to 1550 kilohertz. And then again, 1550 to 4 megahertz, and then the 6 megahertz to 15 megahertz band. So it's got two shortwave bands and a medium band, which you select with the selector switch over here. There's a dial, and probably got a volume and a tone. There's volume and power and tone. This one was brought to me to check over. I'm not going to plug it in until I get it apart. We're going to have to check the paper condensers on here, and there's going to be a bunch of them that need to be replaced. So we'll get working on this and see what it needs, and then I may have to get parts for it if I don't have everything I need, which is a good chance that I don't. But first things first, let's start on this one and take a look at it and see what I need as far as parts and what I have and what I don't have. Need to remove the knobs first. They're held in place with a screw. And no, it's not lying on its side. My hand is under it, as you can probably see. Okay, next we'll remove the chassis. The screw's already been removed from the back. It's actually taped to the top of it, so the back comes off. And the chassis lifts out. There's a couple of screws on the bottom here that need to come out. One is missing. And then we'll see how bad this is. The fellow that owns it had tried running it, so hopefully he hasn't damaged anything with capacitors that have turned to resistors. Got an old AC power cord that should definitely be replaced, I think. These old ones were quite the fire hazard. It's a cloth covered power cord. I don't know if that's a resistor cord or not. Some of these were resistor cords. I don't think so. I think someone's just spliced that on a new cord at one point. Slide out the chassis here, and the speaker probably needs to unplug. AM antenna here, antenna and ground wire. No, you know what? That speaker needs to come out. Yeah, the speaker's not gonna. It's not gonna release it because the speaker magnet is holding it up. So I have to remove the speaker. Fortunately, there are some screws inside that make that easy. And when I say speaker magnet, I'm referring to the electrostatic field coil, because this is what they call an electrodynamic speaker with a electromagnet field coil to produce the magnetic field. They run the V+ from the power supply through this field coil first and then back into the radio. Now the chassis will lift out with the speaker. This is an electrodynamic speaker. It has an electromagnet on the back, and you see someone spliced this wire here for the speaker itself. Inspect the tubes on it. Make sure that there's no broken tubes. It looks like there's still getters on these, so there's been no leakage on any of these tubes that I can see. That's good. Okay, I'm just going to remove the cabinet, get that out of the way for safekeeping, and then we can look at the chassis. Remove the bottom cover so we can see the guts. Wonderful. It's got a few paper caps in here that really do need to get replaced. I got a couple 0.2s here, 600 volts. That's tone. Okay, so these ones aren't that critical because if the tone is kept to high, they're switched out. If we look at this as just a switch, this is the volume control here with the power switch. This is the band select switch, I should say. And this one here is the tone switch. If we get a close look at that, all it is just a 3-position switch that switches high, mid, and low. And it just changes to 2 different values of caps to filter out the high frequencies. So these ones here aren't going to be critical. It's the coupling caps that are going to be critical, and the wiring in here. A lot of times this wiring, the insulation breaks down and it needs to be rewired. So the fellow that owns it basically wants me to give it a once over and see what it needs and give him an idea what he's looking at to repair it. So right now this is just kind of an inspection. This insulation is rubber and it's going to be cracked. So these are radios that you do not leave plugged in. They are a fire hazard. You don't leave these plugged in when you're not actually using them. They're great for conversation pieces, but saying that, a lot of people don't want to spend a lot of money, doing a lot of work on some of these things because the restoration work on one of these, it would be expensive. If you have to start replacing all the wires that the insulation's crumbling on. Of course, if they're not touching anything, then we don't need to really worry too much about it. It's more just the caps, the coupling caps are the ones that are of a concern, that couple one stage into the next. Those are the capacitors of concern, and there's not a lot of them. You got 1, 2, 3, 4, maybe 5 here, and then the main filter cap up here, which can be replaced, and that's these wires I think coming down the bottom here, and that can be replaced with electrolytics in the bottom here, and just leave that just for cosmetics, right? This is going to be, I think it's probably this is the, that rectifier? Might be the rectifier tube. That's a rectifier tube. This one will be the audio output. That's the audio transformer. And we've got some oscillators and IF back here, the RF tubes, they say. Maybe first things first, we should see if it actually tunes in anything. I'll put it on the dim bulb before I do anything else. I'll put it on the dim bulb and just see whether it powers up. See whether we get any noise at all out of it. Okay, let's turn it on. And we'll see that it is drawing a little bit of power, not drawing excessive amount, so there's no dead shorts to start with. We'll see if there's any sound that we hear. It would indicate that the amplifier is working and that we've got some B+. I hear it starting to hum a bit, which is a good sign. I don't know which one of these is the antenna and which one is the ground, but one of them is one. That's why I'm touching it, just to see whether I can couple in some signals. This cap has two 8 microfarad at 450 volts each, and a 10 at 25. So this is a three-way cap. Again, I'm on the reduced power. If I just touch, I'm not touching anything myself, so I won't get a shock. So the audio amplifier is working. So we know that part's working. We've got some B+. Don't know what the voltages are, but we can check them. So our voltage is very low. We're only getting about 60 odd volts. Of course, I'm going to the chassis ground here, which is 227 volts there. I'm starting to hear stuff coming. I'm going to put this on full power. We might actually get something going here. That static is more than likely the electrolytic capacitor starting to reform a bit. Give that switch a shot of cleaner, and I'll just put the knob back on here just so I can switch it back and forth a few times. one's probably the antenna here. This one's ground. Let's see if it's grounded. Is this one ground? Yeah, okay, that one's ground. So this is the antenna. That tuning capacitor looks to be pretty dirty, dusty. I'm going to get the air compressor out. We'll blow the dust out of that, the tuning capacitor. See if it'll tune anything in. See what I mean, right? It's all dusty. See if anything's getting hot in here. There's a wire here. It looks like it's getting warm right there. That wire there certainly is starting to heat up a bit. Where's that going to? I'll use the infrared camera to see if there's any capacitors that are getting warm, because if they've turned into resistors, they are going to be warming up. That's a resistor. Got some sound out of it. Now it doesn't have much sound. This is coming from my test transmitter on the other side of the shop. We've got a good strong signal in here, but it's able to tune it in, so that means that things are starting to work.
Along with you, it's the weekend, and that means it's going to be rainy. Yeah, apparently a big rain tomorrow. Could be 17 millimeters. The good news is hopefully not torrential, and hopefully no wind.
The volume control is quite noisy still.
Future Foundation's annual fundraising gala. Christmas, a transformative evening in support of humanitarian medical mission. May 30th at the Carlu in Toronto. Responsibility.
It's funny, you know, I hear they've gone to one of the commercial splits now again, so they're advertising stuff for Toronto. The station I listen to out here in Vancouver, 98.3, the studio's here in Vancouver, and they broadcast on the FM band, as I've explained before, in Vancouver, but I picked them up off the internet because their signal is pretty weak. With an outdoor antenna and a car antenna, I can get them, but inside here without a good antenna, their signal's pretty weak because they share the same frequencies as another station out in Chilliwack, and this Chilliwack station sometimes overpowers them. So it's kind of a double-edged sword, because if I go up with an antenna, move the antenna higher, the Chilliwack station tends to come in. So the antenna being lower is better, but the signal, again, is not very strong. So I picked them up off the internet, and I just have it rebroadcasting on my little test transmitter here for use around the property on both AM and FM. When I turn on the AM one, that is, for testing stuff, and I can pick it up no problem. But when they run ads on the internet feed, they're running ads for Toronto and Ontario, because the station's carried in Ontario on a couple of FM stations that they also own in Ontario. The same owners own about 7 stations. So the studio's out here, so all the programming comes out here from the West Coast, but they're carried in the East as well. So listen to the internet feed, you hear the commercials and stuff that's heading for the Ontario market, which is kind of funny. Also, when the provincial emergency program kicks in, I heard a tornado alert the other day come through on it, because again, it's the secondary feed that we're picking up here off the internet. Anyway, got the schematic. This thing's working. So I mean, it's going to need caps for sure. It's going to need some caps. I haven't changed anything yet. I just wanted to see whether it actually does work, but it does. It receives a strong signal. So we're going to have to change some of these caps out that are obviously going to be going bad. Just looking here, like I wasn't getting no 400 volts here on the. That's a 400 volt cap. What was I seeing here? See, it should be 180 volts, and I wasn't seeing that when I was measuring the voltage on the plate to the output. That's probably because the main filter caps themselves are weak. That's the electrolytic is weak, so that the B plus is a little bit low, or the B plus could be low because one of the caps feeding into it is bad, and it's causing the tube to go into conduction, which of course is not good. That's why I'm not running it for more than a couple of minutes at a time, because I don't want to damage any transformers. Running an old radio with bad caps in it is not good for it, and that's why I say I've only been running it for just a few minutes at a time, just to see whether it's actually doing anything. So now that we know that it is, I'm going to get in and start changing some of these caps. Like this one here, C16, which is a 0.05 microfarad 400 volt. The number, so 42 is the number of the tube. That's the output tube. But that one for sure has got to be changed out for sure, because that one is a blocking cap to block the DC coming in from the plate of the second detector and automatic volume control tube. So that one's got to be replaced first. That's a critical one. So it's a 0.05 at 400 volts going down here to this tube. So let's find it here. Unplug the power, and it's going to be going to this tube here. So it's a 0.05. It's probably this one right there. See what that is. We're going to change a couple of these and see what it does. I just got to find the right ones. 0.05 at 400 volts. Okay, I think we'll find a cap and we'll change that one out. We'll start with this one. And we'll just work our way back and change out some of the ones that definitely need to be changed, and then we'll see how it sounds. Let's just throw the meter on here for the hell of it. My meter that can measure about 100 megs. See what this thing, whether this thing will even measure it. Measuring 0.1. I think that's probably pretty normal for these old caps. Well, that looks like this cap has got about 11 mega ohm short. See that? It's not rising. This should be going up to infinity. And it's not. I got the probes on here. So that one's bad for sure. That's a leaky cap. Electrically leaky. That's how you can measure them, right? You can measure them if they've got resistance to them. So we'll change that one. I mean, that needed to be changed, but that's a critical one. So we'll put the new one in here, and we'll check a few of the other ones. And as I said, there's not a lot that need to be changed, but there are a few that are critical, and they must be changed. And this is one of them. So the one beside it as well, this 0.1 probably needs to be changed out as well. This one goes up here. We can just put the insulation tubing over the new cap, and we'll just connect it right where it came out of, and under this wire. To disturb the wiring as least I can, as if the wires aren't shorting right now, I don't want to make them short, so I want to make sure the wires aren't obviously touching each other. But okay, that's one critical cap that's been changed out. Let's take a look at some of the other ones. This is a 0.1 at 400. Let's see where that one is on the schematic and see whether that's another one that we need to deal with. If you guys are wondering what this tube is here, that says it's for the M5 or 355 only, that one. This is a 254. That's a tuning eye tube. So this one doesn't have it, so that's emitted. So I continue to change out some of these old paper caps for some little more modern ones that won't have the leakage problems on that the old ones did, and I should have some electrolytics I can put in here to replace the bad electrolytic that's obviously going to be bad on here. But I just want to change the most critical ones, and then we'll evaluate it again. So let me just get in and just change a few of these out, and then we'll check it out again. I just don't want to run it too long with old paper caps in, because when these go leaky like they do, they create all kinds of headaches and potential damage to the unit itself. And I'd say we can check these ones that I've removed so far, and just take a look at how they are for leakage. See, the meter should go to infinite on capacitors, right? And this one here, you know, we're sitting around 21 mega ohms, 19, 20 mega. See, that's basically turned into a resistor. A new cap, for example, if I grab a new one here, and we measure this one here, it should go to infinity, which it does, right? If I short the leads together to start the process, and we connect it, see, it goes to infinity immediately. And these old ones, they are hovering around 16 mega ohms, 19, 20 minutes. That's just that's too low. This should be overload. One nice thing I like about this new meter, this new Must-Tool meter, and everybody asks me what it is. It's a Must-Tool MT13S. I'll tell you that now, so you don't have to ask what it is. The thing I like about this is that the ohms range, it's 100 mega ohms. My Fluke is 30 mega ohms. So you got a leaky cap that's, you know, leaking at maybe, you know, 40 or 50 mega ohms. My Fluke's going to say they're fine. It's going to show overload. Whereas on this one, because it has a 100 mega ohm range, I can test the caps at see, on my Fluke, that would have said fine, because it would say OL at 30 megs. Is this cap, this one, maybe this one's okay. But it's at 45 meg ohm. This should go right up to 99.9 and then OL. If it's 100 mega ohms, then we're, you know, I mean, that's pretty good, 100 mega ohms. This cap here is, leakage is around 50, 57, see, but it's getting up there. Maybe it will get there eventually. 60 mega ohms. seems to be sticking around 62. It's not going any higher than that. So that's bad, that one. And this one here is another one. Oops, not making a good connection there. Just try that again. I cut these off pretty short. You know, 63 meg ohms, you know, and then we look at a new one, and the new one will go to infinity almost immediately because there's no leakage. And in solid state circuitry, that might not make a lot of difference, but in tube sets, that little bit of leakage, especially when you're dealing with high voltage, that's enough to bring a tube into saturation and really degrade its performance, and in worst case damage either the tube or draw too much current through a coil and heat the coil up. So that's why I keep the operation very, very short, only a couple minutes, so that we're not going to stress things enough that we can burn things out. But if this was left to run for any period of time with leakage like that, then yes, it could definitely cause downstream damage to other parts. And I've changed out 4 of the ones that are the paper caps that are, I think, probably the most critical. I'm just going to try it now and see how it sounds at this point. Okay, so what I've changed now is I've changed the 2 high voltage caps that are in the metal 3-part cap. I haven't changed the small one here, but these other 2 ones, the 8 microfarad, they were shot, they were leaking. I've got some bigger ones in here, go a little bit bigger, but this is the main filter down here, and it goes through the field coil, and then it comes back to this one here. So I just hooked them up to the common point, which is not ground, incidentally. Like you think it would go to ground, but it actually doesn't. It goes, there's a 100 ohm resistor here, 1/4 watt, from the 3-sided cap to ground. So that's what that point is down there. So those 2 filters have been replaced. We'll see how it whether it hums as bad as it did before. And then I'm going to get a hold of the fellow that owns this thing and say, hey, you know, how much do you want to spend? Because really all these wires do need to be replaced for safety. But as you can hear, it's already, let's get a bit of a hum in there. It's probably the 3rd cap in there that is the 3rd one in here is the cathode follower for the output transistor, or the output tube. That one there, it's a 10 microfarad, like I don't know, it's low voltage, but that one needs to be changed out too. I haven't changed it yet. I just want to see what it does, right? And how much of an improvement we've made since I started. So,
the side show, the gong show that's gone on.
Yeah.
The focus here now is about getting the 3 points, isn't it? What has the attitude, what has the atmosphere been with the players now towards what's going to happen here?
Oh my God, I'm going to answer that question.
I've got reception now, so I'm getting all the local stations now, so that's even with it just touching the antenna wire. So this thing is now functional, and at this point I'm going to just leave it. I'm going to finish the video up now. We will change that other cap out as well. I'll do that, but at this point I'm going to stop because I don't know how far the fellow that owns it wants to go, whether he just wants to make it functional or does he want me to change out these wires that really, and I mean, if I don't change them out, just putting some spaghetti over them, like heat shrink tubing over them, you know, disconnect one side, put some heat shrink tubing, shove it down over the rest of it, just so they don't short out, right? Because the insulation is cracking on all these rubber wires. The ones that aren't touching anything aren't a problem, but the ones that might touch against the bottom of the cabinet certainly it could be problematic. I mean, he might not want to go there. He might just say, you know, just tape it up, put some tape on it so they don't touch anything. I'm not going to use it. I just want it as a showpiece. I want to be able to turn it on. That's what most of the people with these old radios do. Is okay, I don't want to play it all day because obviously if you're using it to listen to music or radio or whatever, you're going to run up hours on the tubes. Most of the people that own these radios, like myself, I collect old radios. We have them as our showpiece. When we get friends over, oh, take a look at my old radio. Let's turn it on. Let's see it work. We turn it on, we let it play. And then when we turn it off again, unplug it. Power cord needs to be replaced. That's for sure. That needs to be replaced. As I say, the wiring in here is pretty bad. But this thing is, you know, this thing is close to 100 years old. And this is what I mean. Take a look down here. Where did I see it? This one right down here. Look at this, right? You see the wiring here, this is off of the transformer, I think. But as you can see, the insulation's all cracked. So this, for safety, this needs to be untangled and untwisted, and the wires are literally almost touching. You can see, but this is what we're up against when we're dealing with these really old radios, is that the wiring just really does need to be replaced. And once you start getting into that, you know, he's talking maybe a couple $100 of labor, depending on how much time is needed. I just wanted to get the thing working. And now I can say, yes, it works, and this is where we got to go. If you want this thing to be, you know, safe, and not worry about the thing bursting into flames when you turn it on, we got to address some of these issues on here. So I'm going to close the video off now. We'll leave it at that. We'll call this the preliminary inspection of an old Sparton Model 254, and we'll pick this up again. Hopefully in not too distant future, after I get a hold of the fellow that owns it and just let him know, hey, I've got it making noise, it's got sound. I've changed out, what did I change? I changed 6, I think I changed 6 caps. 1, 2, 3, 4, yeah, 6 caps. That other electrolytic needs to be replaced in here as well. The third one that's inside the, this has got 3 caps in it. So 2 of the 3 have been changed out. The third one needs to be changed for sure, and I'll do the same as this. I'll just stick it in the bottom and cut the wire and tie it down to the wire. Stuff it in the bottom like the others, and then we'll deal with this. Anyway, thanks for watching. We'll catch you in part 2 when there is a part 2. Bye.